Hi folks, we're going to take a look at this question which appeared on one of the classroom worksheets. Okay, so let's read the question. A UFO appears to be flying overhead of the town of Roswell between two tracking stations. The angle of elevation from one station is 42 degrees and from the second station is 52 degrees. If the stations are 1500 meters apart, what is the altitude of the UFO? Okay, so a couple of things here. We first notice that there's no diagram given, so first order of business should be to get a good diagram. And the other thing is this word here, altitude. Altitude is another word for height. Okay, so remember that when we're talking about height, we're talking about the vertical distance. Okay, now let's get to the diagram here. Okay, so UFO appears in the sky. Okay, so here's our UFO, okay, and between two tracking stations, okay, so you've got two tracking stations, but they're not both on one side of the UFO. Since UFO is between them, I know I have one tracking station on one side, and I've got another tracking station on the other side, okay, and we're measuring the angle of elevations to the UFO, okay, so this would be one line towards the UFO, and here would be the second line towards the UFO. And since we're measuring an angle of elevation, we know we're starting from the horizontal, in this case here the ground, and looking upwards. Okay, so we have two angles of elevation. We have 42 degrees and 52 degrees. So when I look at my diagram here, I see that this one here seems to be the smaller one, so I'll call this one the 42 degree angle, and this one here is the 52 degree angle. Okay, and the other piece of information we have is that the distance between the two tracking stations is 1500 meters. Okay, so this is all the concrete information they've given us. These two angle of elevations towards the UFO that's between them, and we have the distance between the tracking stations. Now let's figure out what we're looking for. We're looking for the altitude or the height of the UFO. And as we said, the height represents the vertical distance upwards. Okay, so I'll use this dotted line to represent the height. I'll give it a name, and I'm going to specify here that this is a vertical distance, therefore it's perpendicular to the ground. So we have a 90 degree angle here. Okay, which is really nice because now I've created two 90 degree triangles, one on the left and one on the right. Okay, however, the information that I have, okay, is mostly for this larger triangle, this non-right angle triangle, because not only do I have two angles, I also have a length of one of the sides. Okay, but eventually I want to be working with one of these right angle triangles. So can I use this bigger triangle to get me information about these right angle triangles? Okay, so since this one's a little bigger, I'm going to focus on this left hand triangle. Okay, so I have a right angle triangle, I have an angle, and I'm just looking for now the opposite side. Okay, but the hypotenuse of this right angle triangle is also a side length in this larger triangle. Okay, so the first thing I'm going to try to find is this side length. Okay, use the information in the large triangle, and then once I have this side length here, I can use it to solve this right angle triangle. Okay, so let's take a look at this larger triangle here, and I notice that I don't quite have a side opposite angle pair, but I can find one, because we know that as soon as you have two angles in a triangle, you can always find the third. Okay, so that angle there will just be 180 minus 42 minus 52 equals, let's calculate that, 180 minus 42 minus 52 equals 86. Okay, so this here is 86 degrees. Okay, but now I have a side opposite angle pair, so automatically I'm going to be using the sine law. Okay, so when I'm using the sine law, I always want to start with what I'm looking for. So since I'm looking for this side length, I'm going to put the side lengths in the numerator and the sines of the angles in the denominator. So this is the length I'm looking for, divided by the sine of its opposite angle, so sine of 52, and that's going to be equal to my known side length, which is 1500, divided by its opposite angle, or the sine of its opposite angle, so sine of 86. Okay, and because I have my variable in the numerator, it makes solving it much easier. So in order to isolate x, here the sine 52 is being divided, so if I want to bring it to the other side, I'm going to have to multiply it. So we have 1500 times sine of 52 degrees divided by sine of 86 degrees. And let's solve this here. So let's get a calculator out. So we've got 1500 times sine of 52 degrees. Okay, it's important here to close off the bracket. And now I can do divided by sine of 86 degrees. Okay, and I do that, and we get 1184.9. So x is 1184.9. Okay, let me include that now in my diagram, 1184.9. Okay, but now I have enough information to work with this left-hand right-angle triangle. Okay, so let's figure out which trig ratio I'm going to use. Now that I'm working with a right-angle triangle, I only want to work with sine, cosine, or tangent. So I have this angle 42 degrees. I'm looking for the opposite side, and I know the hypotenuse. So opposite and hypotenuse, I'm going to be using the sine ratio. Okay, so we've got sine of 42 degrees is equal to the opposite, which is h, over the hypotenuse, which is the one I just found, 1184.9, and now I can easily solve for h. So here, if I want to isolate h, since 1184.9 is being divided, if I want to bring it to the other side, I have to multiply it. So 1184.9 times sine of 42 degrees. Okay, and let's calculate that. So I already have the 1184.9 in my calculator, so I'll just leave it there. I just have to multiply that by sine of 42 degrees. Okay, and we get 792.85. Okay, and we go back to our question, and we realize that the units are in meters, so this is 792.85 meters. And there we have the height, or the altitude, of the spaceship. Okay, so just to recap here, again, no diagram, so it was very important to get the diagram, put all the information that was given, and then figure out what it was we were trying to determine. Okay, from there we realized that we couldn't do it in one step. We had to use the information from this large triangle to help us get information for one of these two smaller right angle triangles. Okay, so in the end it was a two-step process. Okay, that's it for now.